In June 2025, the James Webb Space Telescope made history, capturing its first ever direct image of an exoplanet. That planet, 2RCU-7b, a Saturn-mass world orbiting a nearby red dwarf just 34 light-years away. Until now, Webb was known for peering into deep space, observing early galaxies, and analyzing distant atmospheres. But this was different. Webb didn't infer. It didn't measure a shadow. It saw a planet, a glowing orange speck floating in a massive blue debris disk, carved by a world still forming. This wasn't just a scientific win. It was a moment of visual wonder, a glimpse into the birth of another solar system, caught in real time. 2RCU-7b is about the size of Saturn, roughly 95 times the mass of Earth. It's young, hot, and still radiating heat from its formation. It orbits its star at a distance similar to Neptune's orbit in our own system, about 30 AU. What's remarkable is that this is the lowest mass planet ever directly imaged. Most direct imaged planets are enormous, 5 to 10 times Jupiter's mass. But 2A7b shows we can now spot smaller worlds, and that opens the door to finding more. It's orbiting a star called 2A7, part of a young group of stars called the TW Hydra Association. This is a stellar nursery perfect for observing early planetary systems. 2OBA7 is a red dwarf star, small, cool, and about 10 million years old. That's incredibly young. Our Sun, for comparison, is 4.6 billion years old, so this is a system in its infancy. That matters because younger systems tend to have more debris, leftover gas and dust from star and planet formation. These dusty disks make the perfect canvas to spot newly formed planets, especially those still interacting with their surroundings. And that's exactly what Webb saw. Around TWA7 is a glowing blue disk of dust, not flat and empty like our solar system's Kuiper belt, but thick, active, and chaotic. And in that chaos, TWA7b was hiding. We found over 5,000 exoplanets to date, but very few have been directly seen. Most are discovered by the transit method or the radial velocity method. But direct imaging is different. It means literally capturing the planet's light. That's difficult because planets are billions of times dimmer than their stars. It's like trying to photograph a firefly next to a spotlight from hundreds of kilometers away. But Webb, with its coronagraph, blocks the star's light, allowing us to see what's nearby. 2OA7b is proof that this technique works, and it works beautifully. The image that NASA released is nothing short of stunning. The central star is masked, hidden by a coronagraph. Around it, a faint blue halo of dust swirls, a debris disk. And tucked inside that halo is a glowing orange dot, 2WA7b. That contrast, cool blue disk, warm orange planet, is what makes the image so dramatic. Scientists combined data from James Webb and the Very Large Telescope, VLT, in Chile to produce it. And in that image, you can even see a gap in the disk, likely carved out by the planet itself. It's not just a planet in a system. It's a planet shaping one. As planets orbit young stars, they interact with the surrounding debris. In the case of TWA7b, that interaction is visible. The planet is likely responsible for the gap seen in the disk, clearing out dust as it circles the star. This phenomenon is well understood in planetary science. Even in our own solar system, moons around Saturn carve paths through its rings. Here, we're seeing a similar dynamic, but on a much grander scale. The planet isn't just sitting there. It's influencing, reshaping, and clearing space around it. It's doing what planets are born to do, organize chaos into orbits. James Webb is no ordinary telescope. It sees the universe in infrared, not visible light, allowing it to detect heat from distant galaxies, forming planets, and dusty disks. To image TWA-7b, Webb used a coronagraph, a tool that blocks the star's light so faint nearby objects can be seen. Think of it like using your hand to block the sun to see something dim beside it. Then, scientists processed the data and combined it with images from the Very Large Telescope to reveal something incredible: a glowing blue debris disk and a small, warm orange dot. The planet. This moment didn't just happen. It took decades of engineering, perfect optics, and precision science. And it worked. Because of Webb, we've seen the birth of a world. This isn't just another exoplanet. This is James Webb's first, and that means something. It's the first time we've watched Webb see a planet. Not detect it, not guess at it, see it. It validates everything the telescope was designed to do, and it opens the door to new science. If we can image a Saturn-mass planet, we're getting closer to imaging Earth-sized planets too, especially around dim red dwarfs like TWA-7. That means one day we may see a planet like ours, orbiting a nearby star, and know it's real, not just a curve on a graph. What's so exciting about TWA-7b is that it's young. Just like its star, it's about 10 million years old. That means it's still cooling, still glowing in infrared, still interacting with its environment. This lets scientists study planetary formation in real time. How does a planet clear a disk? How fast does it form? How long does it take for atmospheres to develop? TWA-7b offers answers. It's a living lab floating 34 light-years away, helping us piece together the story of how solar systems are born. It's easy to look at the image and see just a dot. But in that dot is a world. One with storms, moons, maybe even rings. We don't know the details yet. But that's the journey. Today it's a pixel. Tomorrow it's a planet with weather maps, cloud patterns, and maybe, one day, even signs of life. Every giant leap in science starts with a faint signal, and Webb just gave us a new one to follow. This is how we move forward, one dot at a time. James Webb has already changed how we see the universe. Since 2022, it has captured the oldest galaxies ever seen, studied star nurseries, and revealed chemicals in distant atmospheres. It's spotted water, carbon dioxide, and even sulfur dioxide on alien worlds. But this discovery, its first direct image of a planet, is something else. It's not just data, it's a picture, a real, visible sign of a world out there, and it shows what Webb can do, not just in deep time, looking billions of years back, but right here in our cosmic backyard. This is the telescope's legacy unfolding, one discovery at a time. This is only the beginning. Now that Webb has proven it can image a planet like TWA-7b, it can go further. Other systems, like Beta Pictoris, HR8799, or even TRAPPIST-1, are next. Webb might soon show us planets forming together, moons taking shape, or disks being sculpted in real time. And maybe one day, it'll capture a planet that looks like home, with oceans, clouds, and continents. What was once science fiction is becoming science fact. TWA-7b is the first of many. The path is clear, the technology works. Now it's just a matter of where we look next. This image isn't just a pretty picture, it's a dataset packed with answers. From TWA-7b's mass and heat to its orbit and the gap in the disk, every pixel tells a story. That story will fuel research papers, guide new missions, and refine our models of how planets form. We're learning how gravity carves space, how disks evolve, and how young worlds grow. This one photo from Webb is teaching us more than years of theory alone. It's a snapshot of planetary evolution in action, and we're lucky enough to witness it. There's something powerful about seeing a world for the first time. It sparks curiosity, wonder, perspective. Somewhere 34 light-years away, a planet is quietly orbiting its star, glowing, sculpting, existing. And now we know it's there, because for the first time in human history, we've seen it. This isn't just about science, it's about our place in the universe. Every time we see farther, we understand more about where we come from and where we might go. Tusue 7b is part of that journey. So what comes next? James Webb is only getting started. More planets, more young stars, more systems still wrapped in dust. And maybe one day, a pale blue dot, a world like ours, seen not just in data, but in light. 2A7b is the beginning. A glowing dot, a dusty ring, a new world, and now a new era. Webb has opened the window. The universe is calling, and we are finally learning how to look.